Okay, pre-cal students, in this video we will be studying a process called verifying trig identities. Your heading today will be verifying trig identities. The lesson number will be 10.2, and be sure to include today's date, please, if you would. Always to keep your notes organized that way. Once again, your heading today is verifying trig identities. The lesson number is 10.2, and the date today would be very nice for you to write in your notes. Okay, let's continue on. Here we go. This is a process in which you are given a trig identity and you verify, or in other words, prove it. You verify or prove its validity by simplifying one or both sides until you have an equivalent expression. Okay, so verifying trig expressions or trig identities is a process, and you're going to take a given expression, a given identity, and you're going to make substitutions. You're going to simplify do things to the left side, to the right side, until you end up with an equivalent expression. And I will show you how to do that today. In most cases, it is better to work with one side of the equal sign at a time, although there are exceptions to this. So usually you have one side over here and one side over here. Now, it's okay to manipulate and make substitutions on both sides and do work on both sides. That's okay. But usually you'll do one side at a time, okay, and then kind of work with the other side later if you need to. Although there's exceptions to this, okay, but that's usually how you do this, okay? Let's look at 7 examples and then we'll be done, so you have a little closure that way. You know how many examples we're going to do. We're going to look at 7, okay? And so let's look at 7 examples and then we'll be done. Let's give these a shot and see how you guys do. Before we start, let me give you one word of warning. There are no steps that I can give you. Like in the past when we were graphing sine, cosine functions, I gave you steps. Or tangent, cotangent functions, I gave you steps. There's no steps I can give you. These problems are done by trial and error, okay? The dreaded words, trial and error, and by gaining experience. And of course, the only way you get experience is homework. The more of these you do, the better you will become at verifying these, hopefully, okay? So here we go. Go ahead and copy this first one down if you would, please. Secant squared x minus 1 over secant squared x equals sine squared. I will pause a second while you copy that down. Now remember, what you're looking for is chances to make substitutions and simplifying and stuff like that until both of these sides say the same thing. All right, so here we go. Okay, I'm not sure about you, but when I see secant squared x minus 1, one of the first things I think of, and I'm turning back in my book now to my trig identities, secant squared x minus 1, let me get my pen to work here. Okay, so hold on one second. Okay, students, I'm back. Sorry about that. Okay, here we go. When I see secant squared x minus 1, one of the first things I think of are the Pythagorean identities. When I see a secant squared or a cosecant squared or a tangent or sine, cosine, so the trig identity I'm thinking of is 1 plus tangent squared, 1 plus tangent squared equals secant squared. Now, if I were to bring this 1 over and make it negative, then you can see tangent squared equals secant squared minus 1. So for secant squared minus 1, I can put tangent squared x over secant squared x. Now, students, if you want to continue to bring this down over and over, you can. I just leave it blank over here because right now I'm working with this left side, okay? Now, okay, tangent squared. I'm thinking when I see a tangent, I can put sine squared over cosine squared. That's for tangent. That's called a quotient identity. And then for secant, the reciprocal is 1 over cosine. Now, watch this. The whole reason I did that is because I have one fraction up top now and one fraction in the bottom, which means I can take this bottom fraction here, flip it, and multiply it times the top. So cosecant or cosine squared over 1, and this would cancel, and I'm left with sine squared x equals, and then bring this down. Now, sometimes students, you'll have to work on both sides of the equation, okay? And sometimes you'll do something like maybe you'll have a fraction on one side and a fraction on the other side, and sometimes you'll even cross multiply. Okay, that's okay. But usually you're going to work with one side for a while, then maybe the other side, or just one side, and that's it. Okay, so as you can see, there's no step-by-steps I can give you. It's just practice, practice, practice. Okay, all right, let's move on to this one here. Now, a little word of advice to you guys. a little word of advice. Sorry about that. My son decided to yell there for a second. Okay, a little word of advice. It's easier to take two terms or two fractions and put them together into one fraction or one term than it is to take one term, excuse me, and try to split it up into two terms. So in a situation like this, you probably want to get a common denominator, okay, for this side over here. So my denominator here is 1 plus sine x. So I'm going to multiply this fraction here by 1 plus sine x over 1 plus sine x. Okay, now this denominator here needs to go over here, so I'm going to multiply this fraction right here. I'm going to go ahead and cover this up just for a second. Okay, here we go. I'm going to multiply this fraction here by 1 minus sine x over 1 minus sine x. Now here we go. 1 plus sine x times 1 would be 1 plus sine x, and then 1 plus sine x times 1 minus sine x. Trust me, that's going to be, if you do all the work there, if you take 1 times 1 and 1 times negative sine and sine times 1 and sine times negative sine, you're going to get, in the end, 1 minus sine squared. Now that might be a mistake. Maybe later, maybe I shouldn't have multiplied that through. But if that's the case, if I shouldn't have multiplied this through, I can always factor it back out again later. Okay, I'm going to go ahead and multiply this times this and continue on. Now over here, 1 times 1 minus sine x is 1 minus sine x all over 1 plus sine x times 1 minus sine x would be 1 minus sine squared x. All right, so there we go. Hopefully you've seen what we've done there. And now let's continue on, put my equal sign. Now I have a common denominator. The whole reason you did that was to get a common denominator so that you could put the two fractions together. So here we go. And students, look, this is really simple. 1 plus 1 is 2. So there's my 2. And then sine plus a negative sign, in other words, a positive negative, they're going to cancel out. So my whole numerator is just 2. And my denominator is going to be 1 minus sine squared x. Now, right away, when I see this sine squared x, I'm thinking Pythagorean identity. Pythagorean identity. Remember, Pythagorean identity is sine squared plus cosine squared equals 1. So if I bring the sine squared over and make it negative, 1 minus sine squared is cosine squared. So for 1 minus sine squared right here, I can put cosine squared. All right, and now from there it's really simple to do, students. You really just have I mean, a really fast way to do this, to be honest with you, is just to simply move the cosine up top, and when you move it up top it becomes secant because of the reciprocal. But I guess I'll break it down and show you in steps. 2 over cosine squared would really be 2 times 1 over cosine squared, because look, if you take 2 times 1 over cosine squared, you'll get 2 over cosine squared. And then 1 over cosine squared, the reciprocal is secant squared. So 2 secant squared equals, and look at that, equals the same thing, okay? 2 secant squared x. So let's review what we learned here. First of all, it's a lot easier to take two terms or two fractions and put them together into one term or one fraction than it is to take one term over here and try to split it up into two. So I would advise you to not try that. And then number 2, once again, use those Pythagorean identities when you see those squares, okay? All right, problem number 3. Here we go. Now, right away, again, I'm thinking of my trig identities, guys. I mean, right away, it's the first thing I think of. And I see a tangent squared plus 1. Well, if you look at your Pythagorean identities, 1 plus tangent squared is secant squared. So for right here, I'm going to put secant squared. Now, cosine minus 1, that's going to be a little interesting. Let's take a look at that real quick, okay? Cosine squared minus 1. The original identity is sine squared plus cosine squared equals 1. Now, you want to have a negative 1, so you got to bring the 1 over here. So now I have cosine squared minus 1. But then bring the sine over here, you have a negative sine squared. So you can make a substitution for cosine squared minus 1, but realize cosine squared minus 1 is negative sine squared, as long as you understand that, okay? So negative sine squared. And that's important. That's good because a positive times a negative is going to give you a negative, and look what you want to have over here. You want to have a negative over here, so that's good. Nothing wrong with that, okay? All right. Okay, here we go. Let's see what we have here. What could we do next? We want to get a tangent. Oh, I think I see it. Remember, tangent is the same thing as sine over cosine. So what I could do for secant right here is I could put 1 over cosine squared, because the reciprocal of secant is cosine, times negative sine over 1. And then multiply them. 1 times sine squared is sine squared. Cosine squared times 1 is cosine squared. So we end up with sine squared over cosine squared, of course, negative. And then we're done. Sine squared over cosine squared would be tangent squared x. I'm not going to bring this down. You can see it totally works. Okay? All right. Moving on now to number, number 4 or 5, whichever problem we're on here. Okay? Looks like number 4, I believe. Okay, pre-cal students, when we look at this problem here, the first thing I notice is I have 2 terms over here, and I have 1 term over here. Now, like I taught you in the last problem, or no, 2 problems ago, it's a lot easier to take 2 terms and put them together into 1 than it is to take 1 term over here and try to split it up into 2. So sometimes you do have to go the harder route, but let's try the easier route first, okay? So here we go. Instead of trying to split this, and this is 1 term, that's not 2 terms, they're multiplying, so that's 1 term. Instead of trying to take this 1 term here and split it up into 2, I'm going to take this over here and try to get a common denominator and put them together. And when I say common denominator, you're like, Mr. Earhart, you're starting to lose your vision. There are no fractions. True, but I can take tangent, and I can write sine over cosine x plus, and for cotangent, I can put cosine over sine. Okay? Now, I want to have a common denominator of cosine sine, so I'm going to take this fraction here. I'm going to multiply it by sine over sine to give me a sine cosine in the bottom here. And I'm going to multiply this fraction here by this denominator over here, cosine. So cosine over cosine. So, here we go. Sine times sine would be sine squared. Sine times cosine would be sine cosine. And then bring down your plus sign here. Cosine times cosine. I should put my x's there, I guess. Cosine times cosine would be cosine squared. Sine times cosine would be sine cosine. All right? Equals. Now, I did all that, students, so I could take my 2 fractions and put those together. Okay? So, sine squared plus cosine squared over my common denominator, which is sine x cosine x. Okay? And then right away, students, you really should see this right away. If you don't, then you need to start really paying attention to the Pythagorean identities. But sine squared plus cosine squared, that's 1. Okay? And then look what you have, guys. You split this up. 1 over sine x would be the same thing as 1 over sine times 1 over cosine, would it not? Sure, it would be. 1 times 1 is 1, and sine times cosine is sine cosine. Now, 1 over sine is cosecant times 1 over cosine is secant. And students, I have no problem with you stopping here. Look at this. This is the exact same thing. I mean, cosecant times secant equals the exact same thing as secant times cosecant. So I have no problem with that at all. Okay? Okay. Moving on to problem number 5. Problem number 5. Okay, students, here we go. Let's take a look at this next problem here. First of all, remember what we've looked at already. We've already learned that it's easier to take 2 terms and put them together than it is to take 1 term and split it up here. So what we're going to do is we're going to write these 2 here as fractions and then get a common denominator and then put them together, okay? So for secant here, I'm going to put 1 over cosine. And for tangent, and this problem here is going to be one of these problems where you're finally going to see we're going to have to work with both sides. and even do some cross multiplying in the end, okay? So it'll be good for you to see this. Now for tangent, I'm going to put sine y over cosine y. Okay, now students, let's see what we have here. Look at this. We already have our common denominator, so we're good there. So we have a denominator of cosine and a denominator of cosine, so we're totally good. So 1 plus sine would be 1 plus sine over cosine. And now bring down your right side. Now, the reason I'm bringing this down, I want you to understand the thought process I'm going through when I get to this part of the problem here. Now, think this through for a second, students. When I get down to this point here, I'm looking at the left side, and really, it's not even close to matching the right side over here. And so I'm thinking, wow, what could I really do to this over here, this side, to make it look like this side? I really didn't see a lot. So I'm going to say to myself, well, you know, maybe I should pull down the right side and do some work to the right side, or maybe because I have two fractions that are equal, maybe I can go ahead and just cross multiply and see what I come up with. So here we go. I'm going to multiply here. Cosine times cosine is cosine squared. And then multiply here. 1 plus sine times 1 minus sine would be 1 times 1 is 1, 1 times minus sine is minus sine, sine times 1 is sine, sine times negative sine is negative sine squared. You end up with this right here, 1 minus sine squared. And look at that, students, we're done. I mean, think of your Pythagorean identities. Sine squared plus cosine squared equals 1. If you were to bring the sine squared over and make it negative like this, 1 minus sine squared equals cosine squared. So for this right here, I can put cosine squared. And we're finished, okay? So sometimes you will have to use both sides, maybe even to the point of cross multiplying, okay? That could happen, all right? Okay, I think we got what? 1, 2 left, and that's it? So 2, we're almost done here. So here we go. All right, go ahead and copy this in your notes if you would, please. Okay, students, here we go. Now, when we look at this problem here, the first thing you really should notice, in my opinion, would be the Pythagorean opportunity that you have. Because if you look at the top of the first fraction, you have cotangent squared. And so as soon as I see that, I realize I might be able to make a substitution for a Pythagorean identity right here. So I'm going to go ahead and do that. And remember, the main thing you have to remember when you're solving these, well, not solving, but verifying these trig identities, is that a lot of it's trial and error. Okay, what you're seeing here on the screen is Mr. Earhart. You notice I pause the video almost after every problem that I do. That's because I pause the video and I work the whole thing out and I try different things until I see the method that works, and then I show that to you, because I don't want you to sit there through the video when the video could be 20-30 minutes long and it turns into 60 minutes long because I'm showing you all the things that did not work. So remember, the number one thing you have to grasp is there's going to be a lot of trial and error. Okay, a lot of that. But anyways, having said that, for cotangent squared right here, I can make a substitution of cosecant squared minus 1. Now, you have to learn to look for stuff like this, but remember, factoring is totally fine. And I'm looking over here, I'm saying, wait a second. Cosecant squared minus 1, I know the square root of cosecant squared. I know the square root of 1, so I can factor this. And why would I do that? Watch. The square root of cosecant squared is cosecant, and the square root of 1 is 1 and 1. Now watch why I would do this. Make one positive and make one negative. Now look, 1 plus cosecant x is the same thing as cosecant x plus 1. So this cancels with this. And now I'm left with simply cosecant x minus 1 equals. Now look at this right side. Listen, students, anytime you have one term in the denominator, one term, there's a very good chance you can split that fraction up into more than one fraction, especially if you have more than one term up top, which I do. So I can really split this up into 1 over sine minus sine over sine. And you say, well, Mr. All right, how can you do that? Well, look, guys, if you were to put these two fractions back together again, they have a common denominator, sine and sine. If you were to put these two fractions together, you would get 1 minus sine over sine. So you're just going backwards. Now look at this. 1 minus sine, well, the reciprocal function would be cosecant. Minus, well, sine over sine is the same thing. Anything over itself is 1, and so we're finished. There we go. Cosecant x minus 1 equals cosecant x minus 1. Okay, not too bad. All right, one more, and then we're finished with the video. Again, students, listen, don't get discouraged as you work these out. Okay, it's going to be a lot of trial and error. And again, you're going to see me right now go to the next problem, and you're going to see me pause the video over here, and I'm going to work this on my own first and try different things that work and don't work, and then come back and show you the way that works. Okay, so trial and error is a big part of solving or verifying these trig identities. Okay, pre-cal students, now when I look at this problem here, one of the first things that I notice is I have, if you'll look, I've got two cosine terms, a cosine to the fourth and a cosine to the sixth, okay? And I have a sine, and I've got a sine over here, but they're two different powers. One's the third power and one's the first power over here. And I've got one cosine over here to the fourth power. So I'm thinking, how can I get some extra cosines over here and maybe make this sine to the cubed sine to the 1 or something? I'm just kind of brainstorming here, okay? So as I look at this, I thought to myself, well, maybe if I could somehow work in a Pythagorean identity, see this sine cubed here, and again, remember, it's just trial and error, but I said, okay, I could put sine squared sine x and then sine squared x and then cosine to the fourth. Now let me show you why I did that. I now have a sine to the x here and sine x over here. I have cosine to the fourth here and a cosine to the fourth over here. So I think I might be getting a little closer. Plus, the sine squared here that I really don't want, I can make a substitution for that. Remember, Pythagorean identity, sine squared equals 1 minus cosine squared. So I'm going to bring down my sine and then put a parenthesis and then bring down my cosine fourth to the x. And then for this term right here, I'm going to substitute 1 minus cosine squared x. And wow, look at that. I'm basically done. I mean, look, on the right side over here, what do you want outside the parentheses? Sine x. What do you have outside the parentheses over here? Sine x. And look, if you take this cosine to the fourth and multiply it through, look what you get. You have sine x here on the outside. Cosine to the fourth times 1 would be cosine to the fourth. And then cosine to the fourth times negative cosine squared would be negative cosine to the sixth. There we go. Identical. Okay? So, I hope this video has been a help to you guys. I know these are not easy, and you're really looking at it now. You're probably saying, Mr. Earhart, everything you're doing makes total sense to us, and we get that. It can't be that hard. You're going to be surprised when you have no structure and no one helping you and giving you direction, how difficult the homework will be, okay? And we'll work on the homework, of course, and hopefully that will be a help to you. But I hope this video has made sense to you. Once again, verifying trig identities. And if you have any questions, don't hesitate to call or email.